is Manuel Edwards from Daily Maths Concepts. Today, what we're going to be looking at is Add Math 2021 question 1 and question 2. So guess what? Stay tuned. I will be right back. Determining the remainder when f of x is equal to ax to the third plus 7x squared minus 7x minus 3 is divided by x minus 1. So in the remainder theorem, if we have a factor or if we have anything that actually divides throughout the polynomial, then the remainder is equal to this. So it was divided by this, so the remainder is going to equal to f of 1. This will give us the remainder. And if you notice, this is a negative, but we use the positive, all right? So that's going to give us the remainder. So I need to evaluate f of 1, all right? So here is it. So here's the function. We have a x to the third, so it's going to be 1 to the third plus 7 times 1 squared minus 7 times 1 minus 3. When we work this out, we should get the remainder when x minus 1 was divided into all of that. So what we're looking at now is a, we have a plus 7. This will give me a minus 7 and a minus 3. And if I simplify further, f of 1 would be a minus 3. So here it is. I've got my response right here, a minus 3. All right. If the remainder when f of x is divided by x plus 3 is equal to the remainder determined in ai, find the value of a. In other words, we're seeing here when f of x was divided by x plus 3, the remainder was the same as what we just got, which was we just got a minus 3. That was the remainder for f of 1. So let's know. So if we have x plus 3 being divided into our polynomial, then if we evaluate f of negative 3, all right, that's going to give us the remainder. And whatever that remainder is, it is going to be equated to x minus 3 because we were told that they're equal. So let's go for this. So let's write back the function here. It says f of x was equal to ax to the third plus 7x squared minus 7x minus 3. So that's the function. So we want to evaluate f of negative 3 right now. So we will have ax, which is negative 3 to the third plus 7 negative 3 squared minus 7 negative 3 minus 3. Let's go further. We have negative 27a, positive 9, so that's positive 63. And this is going to give me positive 21. And this is going to give me minus 3. All right. So there we go. I don't have anything for the a, so I'll definitely have my negative 27a. But let's put these together here. We're talking about 63 plus 21 or minus 3. We have 81. All right, so we have plus 81. So f of negative 3 gave us negative 27a plus 81. So now, if we're going to find the value of a in this question, what we were asked to do was that we need to equate these two ideas, right? So then in doing so, this gave us a minus 3, and then f of negative 3 is giving us negative 27a plus 81. So here, we just solve our problem ordinary. So that if I should say gather my A's on one side and gather my constants on the other side, I'm actually looking at A plus 27A, which is equal to 81 plus 3. So definitely I added 27A to both sides and added 3 to both sides. So I'm getting 28A, which is equal to 84. So then at the end of the day, we want to divide throughout by 28. So the value of A is equal to 3. All right, so there it is. We found out that A is equal to 3. All right, let's go further. All right, the other question it says here that we were asked to consider the function g of x is equal to x squared plus open bracket m plus 4 close x plus 4m equals 0, which has real and equal roots. Real and equal roots. Use the discriminant, yes, of the given equation to determine the values of m. You may use the grade provided to assess. All right, so definitely we intend to understand what the discriminant means. All right, the discriminant of a function is this. The discriminant is the b squared minus 4ac. Now, we have 3 cases for this. We have a case where the discriminant could be greater than 0. And when the discriminant is greater than 0, we will have 2 distinct roots. So you might have a case like this, where the graph crosses the x-axis at 2 distinct places. So you could see there are 2 different values. All right, so this occurs when the discriminant is greater than 0. We end up with that case. There's another case where our discriminant could be less than 0, right? So when the discriminant is less than 0, we actually have a case like this. When it's less than 0, it's like the curve will not cross the x-axis. All right, so it's not going to cross the x-axis. And in this case, we do say we have imaginary roots. So our roots are imaginary. Here, the roots are real. All right, here we have imaginary roots because it did not cross the x-axis for us to get an x-intercept right there. So that occurs when our discriminant produces a value that is less than 0. Now, there is the third case, which is the one that we're going to be dealing with here, is when our discriminant is equal to 0. When our discriminant is equal to 0, we actually have real and equal roots. And what does that mean? That's a case where the curve does not cut through, but it just touches the x-axis and go. So it's a case where it doesn't cut through, but it's just going to touch it and go. So we will have equal roots right at that spot. So that's the case that we're going to investigate, where our b squared minus 4ac is equal to 0. And then that's going to help us to walk out of this problem. Now, what we can do in the meantime is identify from the situation what is A, what is B, what is C. Now, A is the coefficient of the square. So this is A equal 1. A is equal to 1. B is the coefficient of X. Here is X. So B is going to be that coefficient. So B is equal to M plus 4. That's what B is. And C is the constant. So C is going to be the constant, which is going to be 4M. So there it is. We have A, B, and C with one variable, M. So definitely we could do something here, right? Let us see how we could walk ourselves out of this situation. Now, imagine that b squared minus 4ac is equal to 0. I could now split the b and the 4ac. In other words, if I add 4ac to both sides, or for short, we say we bring it on the other side and change the sign, we're looking at b squared is equal to 4ac, positive, all right? So that's adding 4ac to both sides. Now, from here, b, remember that b is m plus 4. So we're supposed to square that, and that is equal to 4 times a is 1 times c is 4m. So here we just substituted what we had for b right there, and c and a. All right, so let's continue. So if we should clear this up, right? If we should clear this up, we will definitely get, if we square the first term, so we'll get m squared, multiply 4 times m, and then double that, we'll get positive 8m, and then multiply the last term by itself, we will get positive 16. So that's me taking a quick shortcut here to get rid of that. All right. All right, let's go. And on this left side, we'll have 16m. Now we're solving for m. So if we're solving for m, we want to gather everything on one side, right? Solving for m. So let us gather everything on one side and then let it equal to 0 because we have a quadratic. So we'll have m squared plus 8m minus 16m plus 16, and this is equal to 0. All right, so there it is. Then let us simplify. M squared minus 8m plus 16 is equal to 0. And if we factorize this though, if we factorize this, we have an m here, we have an m there. Definitely we have minus 4 2 times, because this is a perfect square. Because if I take the half of this and square it, I see this number. The moment I do that, and my coefficient here is 1, then I have a perfect square dealing with right there. So then we can see now that's either m minus 4 is equal to 0, or we still have the same thing, m minus 4 is equal to 0. And definitely m is just 4 is just one number. So we could see that m is equal to 4, and we would have solved the situation right there. Let's look at the C part to this. It says, let h of x equal to 2x squared plus 8x minus 10. Express h of x in the form a, open bracket, x plus b, all square plus c. All right, so this is completing the square. What I'm going to do quickly is just to drop the formula. So the h is what most persons are accustomed to, but it is a b value now. You can find that by doing b over 2a. And the k value that we normally see is a c value now, and that is 4ac minus b squared all over 4a. So from this original thing here, let us list out what is a. A is 2, b is 8, and c is the constant, negative 10, you can see here. So we're going to just substitute now to find those values, and then we place them back in this, and we're done. All right, so we want to express it in that form. So b over 2a, b is 8 over 2, a is 2. All right, so this is giving me 8 over 4, which means I'm getting a value of 2. So that b value there is 2 that we're going to be plugged in to our form right here. Let's go for that c value. 4 times a is 2, times c is negative 10, minus b squared, that is 8 squared. All of this is over 4 times a, and a is 2. All right, so we're looking at 8. This is negative 80 minus 64. over 8. And this is giving me negative 144. Yes. So that's giving me negative 144 over 8. So we could quickly, by that we get negative 18. So I could just write it here that my C value is negative 18. So if I'm asked to write this in the form, then definitely let's produce this in the form that we were asked for. So A is on the outside. A is 2, so it's 2, open bracket, x plus 2 squared minus 18. So this is the form that we were asked to write in. All right, there it is. All right, so that's that. Let us see now if there are questions that they're asking. First question says state the minimum value of h of x. The minimum value is always, so if I have this, I have ax plus b squared plus c. My minimum value is any number that I have here. This number is my minimum value. So in this case, we're looking at 18 up there, right here. So there it is, negative 18 is my minimum value. So the minimum value is where y is equal to negative 18. That's my minimum value. Next question, determine the value of x which h of x is at minimum. Now, what we want to understand that is at any maximum or minimum, the only x value of a quadratic that is at a maximum or minimum is our axis of symmetry. So this question basically is asking what is the equation of the axis of symmetry? In other words, what is the x value that is at the minimum right now? This is when we'll take this section and equate it to 0 and then solve right here. So we could take out this, equate it to 0 and solve for x, which is going to give us our axis of symmetry. So we could see that it is x plus 2. So that's what we're going to take out, equate it to 0 and then solve. So in this case, taking 2 from both sides, x is equal to negative 2. So this is the x value where h of x is at minimum. All right, so that's question 1 is done. Let's see what question 2 is. Question 2 is a log question. Here it is. So let's go through this. It says, given that log in base 2 of 6 plus the root of 12 minus log in base 2 of 3 plus the root of a is equal to the log of 10. Find the value of a. All right, let's look at this. We're looking at logs here. We really want to understand that when we're going to be solving log, we try to use a single logs. For example, I need to let this be a single log here in the base of 2. I want to do that. All right, and then on this right side, I'm seeing where this log, they didn't give us a base, which means that we could assume that it's base 10, and then from there find out what is the log of 10 in base 10, and this is going to give us a value of 1. So then we want to rewrite this in an effort to recreate a new thing as we go forward in an effort to solve. So let's see. Right now, remember the log rule that when you subtract in the same base, you are actually dividing if you're going to write this as a single log. So this is what we have. Log in base 2 of 6 plus the root of 12 over 3 plus the root of a. So that's writing this as a single log. And this is equal to the right side, which is equal to 1. All right, because we have established that taking the log of 10 in base 10 will give us 1. Somebody might be wondering where did we get base 10? It's because they didn't put a base, and when they don't put a base, then technically it's base 10. All right, let's go further. So we want to work this down some more now. Let's go. All right, so So the next move that we can take is to say, all right, we can raise the base of the log, all right, to 1, and it's going to equal to everything that we have in here. So let's rewrite this, where 2 raised to 1, all right, is going to equal to 6 plus the root of 12 over 3 plus the root of a. All right. So then at this stage, we can now multiply. We could get rid of the denominator, which means we want to multiply both sides by 3 plus the root of a. So let's go about doing that. All right. So we want to multiply this side by 3 plus the root of a. And we're going to do it here. 3 plus the root of a. So in doing so, we will see that this would have canceled itself on the right side. So on the left side, what we really have is 3 plus the root of a, open bracket, with a 2 to be distributed as in 6 plus the root of 12. So then going forward, we want a, so we want to get rid of the bracket. So we're going to distribute the 2 inside here, all right, as we go forward. So in distributing the 2, we're looking at 3 2's would give us 6 plus 2 root of a, and this is equal to 6 plus the root of 12, all right? What's the root of 12? All right, so we're almost there, almost there. When we look at this, by the way, I'm seeing a common thing here. I'm seeing where this is positive 6, this is positive 6. So technically, if we subtract 6 from both sides, then we are left with 2 root of a, which is equal to the root of 12. Now, there are a number of things we can do here, right? But I could break this down some more, right? So the root of 12, there is a perfect square under that. The root of 12 could be represented as 4 times 3, which is equal to root of 4 times the root of 3, which is equal to 2 root 3. So you could see where the root of 12 can now be represented as 2 root 3. And then when I look at this, technically, I'm seeing the answer is 3 because root 2, and the answer is 3. But let's break it right down so we could get 3. I want to divide both sides by 2. Dividing both sides by 2, 2 cancel, 2 cancel. So I'm left with the root of a equals the root of 3. So if you square both sides, then we're left with a equal 3. There we go. So a is equal to 3 in this case. All right. Let's go on to the next question. This other question here, determine this set of values of x for which 2 minus x all over 4x minus 9 is less than 0. All right, the sort of question that this is, it's a rational inequality, which means that it's an inequation, should say, and we don't have definite values. We have a range of values going on here, and that is why the question would have said, determining the set of values, plural. So what we're going to do here is that whenever you're doing a rational inequation, you need to find the critical values, and then we're going to be testing regions. All right. So what we could do is look at the numerator. Whenever a fraction or a rational number is linked to a 0, then the numerator is 0. So critical value 1, I need to find critical values in order to do this. So critical value 1 is going to equal to taking the numerator, which is 2 minus x, set it to 0, and then find x. So you could see here that x is equal to positive 2. That's critical value 1. I will be using this to assist the process. All right, let's go for the next now. We also know that when we have a rational number, our denominator cannot be 0. So we want to know what is this value here that would have made the function undefined right here. So we'll equate or set the denominator to 0 to get critical value 2. So critical value 2, I'm going to be using 4x minus 9, set it to 0. So I have 4x, adding 9 to both sides equal 9, dividing now by 4. So x is equal to 9 over 4, which is basically 2 1/4. So we're looking at this as the other critical value. All right, this is the other critical value that we have. What do we do with the critical values? We're going to set them on our number line. We're going to throw them on our number line right here. Show them on our number line. Yeah. All right, so we could put them on the number line, and we're going to be doing some tests on them to see what region really helps us in securing what we're looking for. All right, let's go. All right, so here, this is a quick number line. All right, this is a quick number line. So we have 2, which is to the left of 2 1/4. It's to the left of 2 1/4. So these are our critical values. These are our critical values. All right, what region? So what we want to do, though, we are going to be testing between these. What do I mean? I need to find a value less than 2 to positive infinity, less than 2 going to negative infinity, should say, less than 2 going to negative infinity. And then I'm going to be testing. I will be testing between positive 2 and positive 2 1/4. I'm going between that to see what number would have made the function, if I substituted a number there, would have made the function less than 0. And then lastly, I will be testing a number greater than 2 1/4 to positive infinity, anything over that side. So we're referring to positive infinity here, any value over that side. So the markers that we have, one is at 2 and the other one is at 2 1/4. So we're testing in those color regions. Now, test number 1, test 1, I need to use a value for x in that green region. So I'm going to be using 0. Since 0 is a nice number, you have less work. And then when we test that, we want to see, will we get a value less than 0, which means it's all about, do I get a negative or a positive value? That's all I'm testing for. So that's test 1. Test number 2, test 2 will come in this region, and I would have to use when x is equal to probably 2.1. All right, so a value between positive 2 and positive 2.25, so it's 2.1. And then test number 3, I'm going to be using when x is equal to, say, a number greater than 2 1/4, like 3. So I'm going to be substituting these values one at a time in the function, and then see if it's giving me a positive or a negative number. And then that would have helped me to decide on the solution set. All right, let's go. Let's go. All right, so test, I'm going to do my first test here. Test number 1 is when x is equal to 0. So we're talking about 2 minus x over 4x minus 9. So if x is 0, then it means that I am going to be substituting 0 here and here. So let us just do that right away. So I'm going to be having 2 minus 0 over 4 times 0 minus 9. So this is going to give me negative 2/9 overall. All right, so this is a negative number. That means it's less than 0. That means this is saying to me, yes, that region is good for the math. All right, because it makes the math true, the statements true. So I'm giving this a tick because definitely I'm going to be using numbers where x is less than 2. Right, all of those are saying that we did let this work. Let's check a number between, so 2.1. So test number 2 is going to be using 2.1. So let me do it right up here. Test number 2, I'm going to do test number 2 right here. Test 2, where x is equal to 2.1. Let us substitute. We have 2 minus x over 4x minus 9. 2 minus x, so 2 minus 2.1 over 4 times 2.1 minus 9. Let's see what we get. We are getting negative 0.1 at the top. And at the bottom, we're getting negative 0.6. All right, negative 0.6. So negative and negative does give us a positive. So that's a positive number there we're looking at. So that means that won't work, right? That will not work. All right. So this is giving us a positive value, positive. Let me just write it down. 0.1 divided by 0.6. We're getting 0.166. All right. So we're saying this is positive. So this can't work. So no, this region does not work. So nothing there will work for us. Let's go to test number 3, which is the last test now. Test number 3. All right. Test number 3. So test 3 is when x is equal to 3. All right, so we're looking at 2 minus x over 4x minus 9. Let's substitute 2 minus 3 over 4 times 3 minus 9. All right, let's see what we have. 2 minus 3, this is giving me a minus 1 at the top, and 12 minus 9 is a 3. So I'm looking at a negative number here. So yes, this is actually giving me a tick right there. That's yes. When you work out when x is 3, we get a value that is in the region that we want, less than 0. So it's a negative. So then this is telling me that, hey, this works, and x is greater than 2.5 here. All right, 2.25, my bad. X is greater than 2.25 right there. So then let us write up that solution set. All right, so in writing up the solution set, it is such that x is such that we could say that, hey, x is less than 2, yeah, and that will unite with the fact that x is greater than 2.25. There we go. So we're saying that x is less than 2, union x greater than 2.25. And that's our solution set. Why did I put it in a set? Because the question did say set. So you have to use the set notation here, the curly bracket. All right. All right. So there it is. We have found that. All right. Let's go to maybe the last question. All right. The last question says, number 2, C question. It says Alex deposited $4,000 in her new savings account at Bank of Fortune, all right, which pays 8% per annum interest. The bank's compounded interest is represented by the geometric progression here, where A is the amount accumulated after T years, R is the rate percentage per annum, and T a positive integer. Very, very importantly that we look at this, a positive integer, the time in years. Integer, all right, so can't use any decimal, can't use any fraction at the end of the day. Determining the number of years it would take Alex to triple, at least triple, say that triple or more, all right, at least triple. So that means at least 12,000 or more. So here's the thing, P is 4,000. T, we don't know, we're going for that. R is 8% per annum. And the context now is that we're going for a triple. So we want to triple, yeah? We want to triple P, which means we're going to go for what time will it take to make $12,000? What positive integer would it take to make 12,000 or more? The formula was given. So we could start off by setting up this. 12,000 would be the amount that we intend to see, is equal to 4,000, which is what we're starting with, open bracket 1 plus r, which is 8 over 100 times t that we don't know yet. All right, so this is the way forward. All right, let us just take our time and walk ourselves through this. All right, at this time, we could divide this by 4,000. So on the left side here, I'm looking at 3, which is equal to, so this is canceled, which is equal to 1 plus 0.08 raised to the t. All right, so we could simplify inside here a little bit more. So I'm just gonna organize that. So we have 3, which is now equal to 1.08 raised to the t. Now, at this time, when you observe this, I'm dealing with an exponent here, right? T is an exponent, a power. In solving exponential equations, we normally reside on using a common base. For example, this is a base of 3, and I would think, what can I do to 1.08 for it to become a base of 3? I can't. And vice versa, I can't manipulate 1.08 to get a base of 3 either, which means that this is when logarithm comes in. So whenever exponent fails or unable to proceed, then we can log both sides and go. So what we're going to do now is to log both sides. So a log of 3 is equal to the log of 1.08 raised to the t. Applying the logarithm rules that when you have the power here, it automatically becomes a coefficient of the log. So rewriting this, and at the same time, I could take a value, but let's just put log 3 here is equal to t, the log of 1.08. We're almost there, because if I divide both sides by the log of 1.08, then t in years is alone. So what my response is, I just need to log 3 divided by log 1.08, and I'm getting 14.3 years. All right, remember the context of the question. T is a positive integer. This is not an integer, but this would at least give us $12,000. But remember, the question says at least 12. So what year? It can't be 14, because if we go to 14 as an integer, it's not going to be tripled. So we have to step up to 15. So conclusion, our conclusion is 15 years, right? Because 14.33 will give us the 12,000. So we can't go beneath, we have to go further up, and we need an integer. So the next integer after 14 is 15, all right? So 15 years would have produced at least 12,000 or more. Thank you for watching Daily Maths Concept. Please like, share, subscribe, and drop a comment. See you next time when we look at more questions. Thank you.